Thanks for tuning in to the Cultured Meat and Future Food podcast. This show is intended for anyone interested in cultured meat and food technologies. I had the pleasure of speaking with Dr. David Welch of the Good Food Institute on this episode, where we talked about the growth of the scientific movement and the clean meat industry. Most people learn about podcasts from their friends, so please share the link with any friends or colleagues that you think might find this show interesting. David holds a bachelor's degree in biology from the University of California, Berkeley, and a PhD in plant development cell biology from Utrecht University. He has more than 15 years' experience in the life science industry, including the product development, market development, and commercialization of cells, scaffolds, cell reprogramming tools, and cell culture media for regenerative medicine and bioprocessing applications. At GFI, David combines his background in plant biology and regenerative medicine to help companies and academic research institutions accelerate the development of plant-based and clean meat alternatives to animal products. David, I would like to welcome you to the Cultured Meat and Future Food podcast.
Thanks, Alex. I'm happy to be here.
Tell us, David, how did you get involved with clean meat, and what is your current role at the Good Food Institute?
You know, like you mentioned in the introduction, my academic background's in plant molecular biology, and I actually studied stem cells in the root of a model plant called Arabidopsis during my PhD. And so I've had an interest in stem cell biology for quite some time. And then I moved into the life science industry where, as you mentioned, I developed and commercialized a lot of tools for stem cell biology research and cell therapy applications. And along the way, I became vegan, initially for running. I'm an ultra runner and wanted to improve my performance, but I soon discovered there were far more important benefits to a plant-based lifestyle, namely the environment and animal welfare and human health. And as a scientist, I was intrigued by two problems related to the inefficiency of our current food system. The first of which was that a lot of the work I was doing was to develop tools that were used to research diseases of lifestyle by scientists or to actually create drugs to treat them. And, with my newfound knowledge of a plant-based lifestyle and the benefits of it, I thought, well, why not use science to create better foods that can reduce the amount of those harmful foods that people are eating and in turn reduce the need for these drugs. And then the second problem that intrigued me was just the overall inefficiency of the industrial animal agriculture system. If you look at the chicken as an example, which is the most efficient livestock animal, the chicken requires 9 calories of energy in to produce 1 calorie of food out. And so as a scientist or an engineer, if you look at that very simple equation, you sort of immediately come to the realization, well, there must be a better, more efficient way to produce food than that. So why not use science again to create more efficient foods that are less energy intensive and at the same time help improve the environment and human health and reduce the suffering of animals. So, all of that together kind of brought me to GFI, where I could combine that background in stem cell biology and plant biology to work on better ways to create plant-based food and clean meat. So that's how I got to GFI. Now, what do I do at GFI? I'm the director of our science and technology team. And our team is really, our primary goal is to accelerate the amount of research and commercialization in both plant-based meat and clean meat. And I see us doing that through sort of two main pathways. The first is around inspiring and educating scientists and entrepreneurs and investors to help them better understand this space. And we perform a lot of foundational research on the current state of the clean meat industry and help scientists identify opportunities for research that we think is going to move the industry forward. And a lot of that is focused on scientists that are in adjacent areas of research, like stem cell biology or tissue engineering, to help them understand how they can take their skills and apply them to the research problems that exist within clean meat. We've also published some nice white papers and articles. We recently published a review of the clean meat industry in the Biochemical Engineering Journal. That's an open source paper, so I'd be happy to provide a link to your audience to take a look at that. And we also help educate scientists through courses. So Alison Burke in my team, she helps run a course on alternative meats at UC Berkeley. And she's developing a MOOC or an online course to provide the same type of resources and education on a global scale. And then alongside that, those educational activities, we also work to mobilize funding so that research can actually happen. So we work with a lot of generous donors to allow their funds to be applied to both plant-based meat and clean meat research. A great example of this is work that we're funding in Dr. George Church's lab at Harvard University. A scientist there, Marie Gibbons, is working to create a clean turkey cell line. We're also working to launch some competitive grant programs later this year that will fund research into clean meat. And then we also work with investors, so we help them better understand the clean meat industry and the new companies that are starting, so they can better allocate their funds. And with public funding organizations, just last week I was at the National Institute for Food and Agriculture, which is a division of the USDA, to help them better understand both plant-based meat and clean meat and how areas of their funding can be applied to research in this space. And then, if I think out a few years, one of the projects that's really exciting to me is to bring together all of this funding and all of those scientists that I spoke about and create a clean meat research center at one of the top universities here in the US, so we can bring together those sort of cross-disciplinary areas of various science disciplines and engineering to make this research that's needed to happen in clean meat happen.
What do you think is the main factor for the increased interest in plant-based meats and foods? We used to have veggie burgers for vegans and vegetarians, and now we're really marketing veggie burgers to the masses. Do you think it's an environmental aspect, or do you think that the interest in meat alternatives has increased since the announcement of the first lab-grown hamburger?
Yeah, this is a great question. Despite people being more aware of the harms of industrial animal agriculture, meat consumption continues to increase on a global scale. However, the shift towards plant-based foods, I think, is really being driven by millennials, or the so-called flexitarian. And these people are more likely to consider the food source, animal welfare issues, and environmental impacts when making their purchasing decisions. And they're really demanding better products to replace the meat products that they like to eat. And now there are better products that appeal to the masses. Some great examples of these are the Impossible Burger or the Beyond Burger, that are really far more similar to animal products than the veggie burgers that we've been used to over the past 10, 20 years. So we're really starting to see the biomimicking of meat for meat eaters. And I think in parallel to that, some of the funding success by the new clean meat companies like Memphis Meats has created a lot of buzz in the media and in the entrepreneurial and investment communities. And we've seen a lot of growth in the number of clean meat companies over the past 12 to 18 months.
I want to jump back to a couple things that you mentioned. Tell us a little bit about what ultrarunning is. And as someone who is vegan and has a plant-based diet, would you personally eat cultured meat?
So ultrarunning is defined as any race distance that's over a marathon. I've run everything from a 50K, which is just over 30 miles, to a 100-mile race. I've done 5 100-mile races. So It's a passion of mine. I do it on a fairly regular basis. This year, I'm attempting something called the Beast Series, which is it's a series of 6 ultra distance races, 350Ks, one 50-mile race, 100K race, and one 100-mile race, all in one calendar year in the mountains of Virginia. So I'm in the middle of training fairly rigorously for that at the moment. And then in terms of, would I eat clean meat? I don't have a strong need to eat animal meat, but from a scientific perspective, just from sort of the curiosity of a scientist, I'm curious to try some of the clean meat products. I've not had a chance to do that yet, but I'm very interested to experience that. I'm not sure I'll be the best test case since I don't eat meat, but I'm very curious.
So let's get a tad bit technical. Tell us exactly what stem cells are in the scenario of tissue culture, and how do you exactly identify these particular cells from an animal?
You can categorize stem cells into 2 broad categories, first of which would be pluripotent, and those are stem cells that can essentially become any cell or tissue type in the body. And then you have multipotent stem cells, which have a restricted differentiation capability. So they might just be able to form a couple of different cell types in the body. And scientists in clean meat companies and scientists in academic settings are really at the moment looking at all of those different stem cell types to understand which are the best cells to work with to create the different types of clean meat. These cells can be extracted via a very small biopsy. If you take, for example, induced pluripotent stem cells, these can be generated from a blood sample or a skin sample. So these are very non-invasive procedures. Once you have that very small biopsy, you can sort those cells via specific biomarkers so that you have a population of cells that is just that stem cell type. And then you can proliferate those in so-called cell culture media, which is essentially a nutrient broth that's providing all of those nutrients that cells need to grow and proliferate. Once you've got a specific volume of those stem cells, then you can tweak the culture conditions to push those cells down a particular differentiation pathway. In the case of clean meat, you're going to want to push those stem cells to become mostly muscle, but also fat and connective tissue. And all of that is being done inside a bioreactor, which maintains the appropriate growth conditions for those cells.
So we hear a lot about fetal bovine serum, and the fetal bovine serum being a necessary part of the equation, a very expensive part of the equation. What could be a solution to replace the need for fetal bovine serum in culture media?
So I don't see fetal bovine serum as a necessary part of the equation. In the biomedical industry, scientists identified fetal bovine serum, or FBS, as one of the main causes of reproducibility issues in cell culture, 10, 15 years ago. And as a result, there are many, many serum-free and animal origin-free media formulations on the market today. So the technical challenges of removing FBS in cell culture and replacing it with something that is serum-free and animal origin-free has been solved. Now, the challenge we have with clean meat is that these media formulations are very expensive. A lot of that's due to the ingredients, some of the growth factors that are used to either maintain the cells in a pluripotent or stem cell-like state or push them towards specific differentiation pathways are very expensive. And they're also produced for the biomedical industry, so they have different quality requirements. And they're not currently produced at the scale that would be needed for clean meat applications. The work that one of our scientists, Dr. Liz Speck, has done on serum-free media formulations shows that we can actually reduce the cost of these formulations down to a level where it would make clean meat production at scale possible. So all of this, from a technical perspective, has already been solved. Now what we need to do is to reduce the cost of these serum-free media formulations. And this is going to require work with some of the large ingredient companies to create food-grade versions of these components that are used in serum-free media formulations. And we'd love for a company, either a new startup or one of the existing cell culture media companies, to look at this space and these problems and start to create food-grade serum-free media formulations for clean meat applications.
You had mentioned 9 calories in to get 1 calorie out for the chicken. What would kind of be the ratio for clean meat?
I don't think we know that exact ratio yet. There have been some life cycle assessments done for clean meat, I think 2 or 3 studies, and all of them indicate that it is going to be a far more energy-friendly system than the current system that's used to create animal meat. We have a scientist, an environmental scientist on our team, Isaac Emery, who's beginning a very complete and thorough life cycle assessment of the clean meat industry. So all indications show that it is a far more efficient system, but that exact ratio is something that I'll have to get back to you on.
The first cultured meat hamburger did not really have any fat. In the process of creating future meat, would we be cultivating fat and muscle cells together? Or are they combined later? Or even would we be using a totally different type of fat?
So this will depend on the clean meat product that's being created. Are you creating a burger or bacon or, a more complex food product like a marbled steak? In the case of a complex meat product, you're likely going to need scaffolds and perfusion bioreactors to co-culture multiple cell types together. A perfusion bioreactor is a device that allows cells to culture continuously by feeding the cells with fresh cell culture media and removing spent media while keeping those cells in culture. So you're going to need that complex system, but that would allow scientists to culture those fat and muscle cells together. In the case of a more simple product like ground meat or sausage, the muscle and fat could be combined at a later point in time during the production process. One of the interesting thoughts around clean fat is that you could actually create fat with a better nutritional profile. So, for example, with less saturated fat or more or better ratios of omega fatty acids. Another interesting area, I think, around clean fat is that you can imagine hybrid products in the future where you might have what is mostly a plant-based burger, but incorporate some clean fat to give it that perfect taste, texture, and mouthfeel that consumers are looking for.
That's cool. And, I heard that there was a company that was able to get, I want to say it was like mammoth cells and kind of create, I think it was a collagen. This might have been Geltor. Do you think that we might be able to create meat from extinct animals in the future?
So as long as you've got the stem cells from that animal, in theory, you can proliferate those and then differentiate them into muscle, fat, and connective tissue, which is meat. So from a very basic technical perspective, if you've got the cells, you can create the meat. Whether we'll see that happen in the next few years, I'm not sure, but I think this does open up an interesting area of both research and innovation in that, do we really need to stick to the livestock animals that we currently use to create meat, or can we look to other animals that potentially have better nutritional profiles for meat instead of a cow or a pig or a chicken? So I think this is a really interesting area of research that we'll see more work done in the future.
There are talks of companies creating cultured meat and clean meat microwave-looking devices for the home, somewhat equivalent to like a bread maker. What is really the minimum amount of equipment you need for tissue culture today from like a cost perspective? And do you think that in the future we might even have these meat makers in our homes?
So you can create a small amount of clean meat in a standard cell culture lab with flasks and an incubator to maintain appropriate culture conditions. I think, if you were to do this on a very basic level, you'd be looking at maybe around $20,000 to set that up. But you could do it for much less on in a home setting. There's an interesting group in Japan called Shojin Meat, which is associated with one of the clean meat companies, Integriculture, and they're actually crowdsourcing clean meat production by educating and equipping students to create small amounts of clean meat at home. So there's already some interesting examples of how you could actually do this in your home. But saying all of that, if we're really going to transform our food system, then we'll need clean meat produced at a much bigger scale than that. And this is going to require very large manufacturing facilities with large bioreactors. So I think this is really where the industry needs to focus, and this is how we will be able to transform our food system. But saying that, we could see small-scale devices to produce clean meat in our homes, but I really see this as a niche market. Someone like the devices that we create today for people that like to bake their own bread at home or brew their own beer.
For scientists and entrepreneurs that are interested in starting research companies in this space, what suggestions do you have to get them started?
First, I would tell them to understand the market. Where are the opportunities for clean meat products? Where are there opportunities for innovation? A good place to start is the clean meat technology mind map that GFI has created. That's available on our website. And also, I would say not to just think about clean meat products, but think about all of the tools that are required for the clean meat industry. The cells that we spoke about earlier, cell culture media, the ingredients that go into cell culture media, scaffolds that are going to be needed to grow cells in three-dimensional environments to create those complex meat products, and even bioreactor technology and the large manufacturing facilities that are going to need to be created to produce clean meat at scale. And, reach out to us at GFI. That's really what we're here for. We're here to accelerate the amount of research and innovation that's happening in clean meat. I think you recently interviewed my colleague Brad, who leads our innovation team, and his team helps entrepreneurs start companies in the clean meat space. In the SciTech team, we're about to launch our office hours, which is a monthly 1-hour session where scientists can dial in and ask members of the science and technology team questions about both plant-based meat and clean meat. So keep an eye out for that as well.
Have you seen a large increase in startups in this space?
Yes, absolutely. So over the past 12 to 18 months, we've seen an incredible growth in the number of companies focused on clean meat. I think, if you look back 2 years, there were just a few clean meat companies, the most notable being Mosa Meat, Dr. Mark Post's company, and Memphis Meats. And now, we're aware of over 15 clean meat companies that have started over the past 12 to 18 months. Some of these are still in stealth mode, but I think over the next year or two, we'll see even more companies both focused on creating clean meat and then companies, like I mentioned before, that are creating tools for the clean meat industry. It's a really exciting time.
You can learn more about Dr. David Welch and the Good Food Institute at gfi.org. David, are there any last insights you may have for our listeners today?
Well, I'd first like to say thank you for giving me the opportunity to be on your podcast. I've really enjoyed myself. And finally, I'd just like to say how excited I am about the potential of the clean meat industry. Just going back to that problem statement that I mentioned in the beginning about the chicken and the 9 calories in and 1 calorie out. I think, scientists are going to be intrigued by that question and finding ways to create solutions to that through clean meat and to solve those problems of the environment and human health and animal welfare that our current industrial animal agriculture system causes. And there's so many research and innovation yet to be solved. And we need more scientists and entrepreneurs to do that work. So if you have any questions, feel free to reach out to me at GFI. My email address is on the website, and I'd be happy to hear from your audience.
David, thank you so much for being with us today and sharing your insight on the Cultured Meat and Future Food podcast.
Thanks, Alex.
This is your host, Alex, and we look forward to being with you on our next episode.